Hello, Big Red's Honors Group. This is part 5. This part is only for you. This is honors. All right, awesome. Let's get going. First, for honors, I'd like you to take out your notes that you did before from the very beginning, video number 1. We're going to expand on that just for honors. So what we want to do is we want to create the equation parallel to AB that goes through C. All right, so first of all, we need to get the points, coordinates of C. Coordinates of C here. C is the point over 2 up 2. So C is the point 2, 2. And I just need to get to go parallel to AB. I need to figure out the slope from A to B. Well, it looks like I'm going down 3 to the right 8. So my slope is going to be negative 3 over 8. So to get an equation that's parallel, I have to plug that into the equation y equals mx plus b. So I put y in 2. My slope is m, so negative 3/8, multiplied by the x value, which is 2, plus b. So when I do this, I multiply this together. I get 2 is equal to, let's see, that's going to be a negative 3/8 times 2 is a negative 6/8, so a negative 0.75 plus b. So I add 0.75 to each side. So I get b is equal to 2.75. So my equation that is parallel to it is going to be y equals, I keep the same slope, which is negative 3/8 x, plus my b value, which is 2.75. All right? Now, if I want something perpendicular to this, I use the same information, but when I take y equals mx plus b, I keep the y the same. The slope, instead of using negative 3/8, I use the opposite reciprocal. So I use a positive 8 over 3. That's what I'm going to use from now on. So use 8 over 3 times 2 plus b. So I have 2 is equal to 16 thirds. 16 thirds is about 5.3 repeating. I'll just round it to 5.3 plus b. Subtract 5.3 from each side. So I'm left with b is equal to a negative 3.3. So my perpendicular equation is going to be y equals, I use the 8 thirds, positive 8 thirds x minus 3.3. All right, so notice the slopes are opposite reciprocals of each other. Very important. So those are honors questions right there. Both of those are. All right, let's go around to the next honors question here. All right, we could do this on the graph here off to the side. Let's do it over here. You could do it on the other side of the graph paper, that's fine. Actually, let's just do that. Flip it over. Why not? Okay, so I'm going to draw XY coordinate plane. Let's say I have a line that I'm reflecting over that looks like this. Let's see, this is the line 1, 2, 3, 4, x equals 4. Okay, and let's say I have a shape, we'll say it's a triangle, that is overlapping like this. And I want to reflect it over this line, and I want to figure out what my new points are going to be. All right, well, you could see this point, let's call this A, B, and C. Well, A is going to stay right there, so A and A prime, since they're right on the line, are going to be the same. B, on the other hand, since it's 1 unit away from this line, is going to go 1 unit to this side, so this is going to become our new B prime. And C is 2 units away over here, so it goes 2 units to the other side. This becomes C prime. So I'm going to connect these. These will be my new points. So my new points would be, A would be, let's see, 4, 3. A prime would be 4, 3. B prime would be 5, 1. And C prime would be 2, 1. That's what you'd have to do for your exam. Though obviously there are different numbers on the exam. All right, let's find our next one. Oh boy, I forgot about this. We have a proof on there. Now the proof that's on the exam is going to be a fill in the blank. So basically, here's what you need to know, okay? Let's say this is D, E, F, and G. And these two have congruent side, a parallel side, and we'll call these 1, 2, 3, and 4. Now these may be different on the exam. It doesn't have to be the exact same. Obviously it's a little different. Now this tells us that EF is parallel and congruent to DG, because these are congruent, these mean parallel. These little triangles here. And what you're going to do is you're going to have a proof, statements, and reasons. You're going to have a bunch of stuff here, blah, 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 blah. A bunch of stuff here, blah, 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 blah. And what you're going to have to do is you're going to have to multiple choice pick how these are congruent. Okay. Well, I can tell you that in the middle, the side they share is congruent. And since these are parallel lines, I have alternate interior angles right here. So I have side, angle, side, congruent to side, angle, side. So the reason for this is SAS. Okay. So just in the proof you have, you're just going to have to fill in a last statement based on your triangle, which may or may not look like this. Okay? That's just one example. And let me just double check. I may have covered the last part of the exam. Yep. That is it. So I wish you, let's see, well, let me just double check one more time. Oh, nope, there's one more. Sorry. Whoa, I almost missed one. That would have been bad, right? Okay, so kind of mid-segment problem. Remember mid-segments, A, B, C, D, and E. And let's say BE is equal to 2x plus 5, and CD is equal to 10x minus 20. So what I'm going to do is, since these are parallel, and while Dr. Gardner is making announcements, I'm going to tell you that BE is half the length of CD, so you have to double BE. So you take 2 times 2x plus 5, set that equal to 10x minus 20. When I do that, I get, distribute the 2, I get 4x plus 10 is equal to 10x minus 20. Subtract 4x from each side, and I'm left with 10 is equal to 6x minus 20. Add 20 to each side. I'm left with 30 is equal to 6x. Divide by 6. X equals 5. All right, that is the last problem. I wish you the best of luck on your exams, honor students, and go Big Reds.